So we have to calculate the minimum and maximum possible areas for each object. So it says the length, and by the way, these are just like the example problems that we did. So the first one is the length and width of a book cover, respectively. So what shape is a book?
Rectangle.
It's a rectangle, right? So they want us to calculate the minimum and maximum areas. So for that, what's the area of a rectangle? Can somebody tell me?
What page is on?
22 centimeters by 12.
Yeah. So well, they're telling you're answering the question, but it's the wrong question. So the length is 22.2, and the width is 12. But how do we calculate the area? Well, the area is equal to the length times the width. But remember, we've been doing some error assessments. In other words, when we measure, we may not be precise. So what we're going to do is we're going to do an increment. In other words, the minimum, the area, the minimum would be equal to the length, which is 22.2 minus 0.05 times, and remember, why did I go 0.05? Because I have one decimal place here, so I'm going to approximate the half here, times 12 minus 0.5, right? So I could do that on my calculator. Get your handy dandy calculator, fire those bad boys up, and I'm going to say in parentheses 22.2 minus 0.05 times the quantity 12 minus 0.5. So we're taking the half increment of the lowest measurement, the lowest significant figure. 12 is to the ones spot. That's the lowest digit that we go that's significant is in the ones place. So I'm going to go to the tenths. The lowest we go here is the tenth space. So I'm going to go 0.05, which is the hundredths, a half of a tenth. And then we're going to subtract. That's the minimum. So when I hit enter, I get the area minimum is going to be, well, let me make sure. Yeah, they want the area minimum, which would be 254.7. So I'm just going to round that to 255. Why did I round it to 255? Remember, when we multiply, we have to go with the least significant, right? So since this one goes to the one spot, we got to round to the one spot. Now for the area maximum, we do the same thing, except we're going to add, in other words, we'll say 22.2 in parentheses, but now we're going to add 0.05 times 12 plus 0.5. So the same thing, except now I'm going to add the 0.5. So I'm going to say in parentheses 22. You guys should be doing this on your calculator too. 0.05, close parentheses, open parentheses, 12 plus 0.5, close parentheses. And I would round that to 278. So then this is the area max is 278. And these are both in centimeters squared, and in the textbook, they said the area lives between 255 centimeters squared and 278 centimeters squared. Okay? Any questions on that?
No.
All right, let's do the next one. Same thing with the next one. So now I'm going to say the area minimum is equal to the length, which is 19.5. Now I'm going to subtract something. What do I subtract?
You subtract 14.
No. 0.05. Very good. Times 14. Now I'm going to subtract something from 14. What am I going to subtract? 0.5. We're only going one decimal place beyond the measurement. Okay? So let's do that in our calculator. I'm going to say, let me move this over so I can see it. 19.5 minus 0.05. Oh, we got to put it in parentheses. And then we say 14 minus 0.5 and hit enter. Now, what's the least precise measurement to the one spot? If I round that to the one spot, what does it equal? 263, right? So our area minimum is about 263 centimeters squared. Now let's do the area max. My area max is going to be the same thing, but instead of subtracting, I'm going to add. So I'm going to say 19.5 plus 0.05, and then multiply that by 14 plus 0.5. So hard to write this on the calculator, or I mean on the tablet. So now I'm going to do the exact same thing. I'm going to start parentheses, 19.5 plus 0.05, close parentheses, times 14 plus 0.5, close parentheses. I'm going to round to 283 because when we're rounding to the one spot, that means I go 1 unit to the right. It's 4, so you would round down. So it rounds down to about, and I got to change this. I want to use the approximation symbol, not the equal symbol. I'm going to say about 283 centimeters squared. Same thing here. We're going to write the word, and let me put it in a different color so it makes sense. We're going to say that the area, that's not a different color, is it? The area is between, oh, you know what? This should be an equal sign because it can equal this too. So I'm going to put an equal sign. The area minimum in this case is 263 centimeters squared, and then 283 centimeters squared. Okay? Let's do the next one. Chris is painting a wall with the length and the width. So on all these problems, we're basically doing the same thing every time. So the area minimum is equal to 3 minus 0.5 times 1.6 minus 0.05. Again, I just plug that in my calculator to figure out what it is. Start my parentheses, 3 minus 0.5, close parentheses, times 1.6 minus 0.05. You guys should be plugging this in your calculator as well. And I got 3.8. We have to go with the least precise measurement. 3 is just the ones spot. So I got to round this to the one spot. So what's the closest one, 3 or 4? 4. So I'm going to round that to 4. So the area minimum is about 4 meters squared. See, I got to read the sentence to make sure it's in meters. Now, for the area max, I'm going to do the exact same thing, but instead of subtracting, I'm going to add. That's supposed to be a plus sign. Plus 5 times 1.06, or I'm sorry, 1.6 minus, I'm sorry, plus, so hard to write with this, 0.05. Again, I'm going to plug that in my calculator. And I'm going to say 3 plus 0.5, close parentheses, open new parentheses, 1.6 plus 0.05, close parentheses, hit enter. I'm going to round that to what number? 6. Very good. So we're going to round that to 6. Meters squared. Okay. Let's see what we have left. Oh man, there's a whole bunch of these problems we got to do. Let's do this last one, and this will be a good breaking point for us to have a conversation. So on this last one, I'm going to say the area minimum. Help me finish this, you guys. The area minimum is equal to what?
15.5 or minus 0.5.
Very good. Times
24.1 minus 0.05.
good. And let's write this out. So the area max is going to be the same thing, except we're going to add 0.5 instead of subtracting. And in this one, we're going to add 0.05. So plug those in your handy-dandy calculators and tell me what you get. I'll ratio. I'm going to say 15 minus 0.5, close parentheses, open parentheses, 24.1 minus 0.05, close parentheses. Oops, did you see what I did? Accidentally hit 2. All right, so what do I round to? What's the lowest, the least precise measurement? What value spot? Well, 15 is the least precise. That's to the 1 spot. So I got to round to the 1 spot. So what is that rounded to the 1 spot? It's 349, right?
Yeah.
So this is 349 feet squared. Actually, I think we'll just finish this whole thing. So now I got to do the same. I got to do the same thing, but instead of subtracting, what do I do? Add. So we're approximating based on an overestimate or an overmeasurement or an undermeasurement. That's what the plus and minus stuff is about. And what does that round to? 374.
Yeah, that's 374. Because that's what you round down.
Okay, cool. Now, I'm just going to keep recording because this is kind of easy. We're going to figure out the significant digits. So here is 1, 2, 3 significant digits. This is 4. This is 5, right?
Yeah.
So how does that work? Well, I've got 4 non-zero significant digits. I've got 1 0 trapped between non-zeros. I'll just say capital NZ. And then 1 to the right of the decimal. So this is 1 to the right, this one over here. How many significant figures? 6. Yep. So you add it up, you've got 6 sig figs on that one. Now this one, I've got 1, 2, 3. Well, let's start with the non-zeros. So I have 2 non-zeros. Then I have 1 0 trapped between non-zero numbers. And then how many do I have to the right? Well, none. So that's it. So I've got 3 sig figs. I'm going to put sig, fig. All right. So now we got to determine the significant figures on this one. So if I'm not going to write it all down. Here's 1 non-zero, 1 to the right. How many is this? 2 significant figures. I've got 1, 2. These are all non-zeros. So how many is that? 6. This is a non-zero and this is a non-zero. So all the numbers in between, if I count them, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let me leave that up there for a second so you guys can read it. Any questions on that? Now, all this other stuff, I'm going to skip this other stuff for today. So don't worry about doing that. I'm just going to skip this stuff for today.